Introducing the Arduino. In this video we will explore exactly what is Arduino, and I'll give a basic overview of how to connect Arduino to a computer and how to get going in one of the greatest hobby microcontrollers on the market today. It's great because it's low cost. We're not dealing with any form of copyrights, patents. It's all open source. It's all free, and it's cheap, which makes it really nice. All right, if we look at the picture in the upper left corner, that is really your Arduino. It is a 28-pin DIP integrated circuit. At a cost of between $4 and $7, it's much less expensive than the Parallax basic stamp pictured on the right. The features of the Arduino, which is based on the ATmega 168 processor, it has 16K of flash RAM. 2K is used for the bootloader. That leaves 14K for you to store your programs. The next step up, of course, would be the ATmega 328, which is the same package, same size, does all the same things for about $2 more, but it has 32K of RAM, flash RAM, as opposed to 16. Of course, 2K is going to be used up for the bootloader, leaving you in reality 30K. The basic 168, of course, has 1024 bytes of static RAM, 512 bytes of EEPROM. Static RAM is where you'll store your variables, math, and so forth. When the power goes off, you lose the data. The flash RAM, where you put your programs, is retained when the power is off. EEPROM is electrically erasable, programmable, read-only memory. It also retains its data when the power is off. I don't see a whole lot of use for it. Some people use it. In addition, the basic Arduino has 6 pulse width modulation outputs. Very useful for controlling light intensity and motor speed controls, and 6 10-bit analog to digital converters. To put it in simplest terms, you can have a 6-channel 0 to 5 volt voltmeter that you can choose from different channels, and with the appropriate software you can literally make a 6-channel voltmeter. The Arduino is a 16 megahertz RISC microcontroller. The clock speed is 16 megahertz. That's a good speed. RISC meaning reduced instruction set computer. What this means is the basic commands of the ATmega 168, which the Arduino is based on, instead of having hundreds of commands, only has 32. You really won't be dealing with those 32 commands because you're going to use a compiler, what is called a compiler, on your PC to write the programs. It will be using a type of C, so you don't have to deal with the torture of having to deal with assembly language. Most important is Arduino has 14 independently programmable digital I/O pins. All right, here's a little bigger outline of the ATmega 168. This shows you what pins are located where. If we go to our upper left-hand corner, of course, we'll have at electrical pin 2 will be digital pin 0. When you program it, you will only be dealing with 0, 1, 2, 4. You don't need to remember that digital pin 0 is at electrical pin 2. The software takes care of that for you. So if we're looking down through here, digital pins 0 through 4 are electrical pins 2 through 6, and so forth. Digital pin 5 through 8 are electrical pins 11 through 14, and 9 through 13 on your digital pins is 15 through 19. On your upper right hand corner is your 6 analog input channels, which are electrical pins 23 through 28. All you have to remember is 0 through 5 with the appropriate command. The software knows where it's going next. One quick more thing to note over here, back in the upper left hand corner is digital pin 0 and digital pin 1, RX and TX, are used to communicate with the serial port on your computer. Those are usually not used for other things. So in reality, you really have 12 digital I/O pins for the most part. I don't like trying to use RX and TX for other stuff. It creates a headache. Notable too is digital pin 2 and 3 have programmable hardware interrupts. I have a tutorial on my website on that. These are quite valuable because an interrupt, when you change an electrical signal on an interrupt pin, the processor will stop what it's doing, go run a routine that you program into the controller, then it will come back where it stopped and continue on. This is like a keyboard on your PC. You press a key, it creates an electrical interrupt to the microprocessor telling it, hey, I pressed the key. This has lots of uses. All right, pictured here is your basic electrical connections for the ATmega. It doesn't take a whole lot to get the chip up and running. You need a 5-volt power supply. You need an external crystal. Now, the ATmega does have an internal crystal oscillator, but that's not utilized for the most part. The Arduino uses an external crystal or resonator running at 16 megahertz. So basically, to get this up running, you need 2 little capacitors, reset switch, another little capacitor over here, and you've got to have this 10K pull-up resistor on pin 1. That helps. That's part of your power-up reset. All right, pictured here is what the programming console on your computer will look like. It's just a compiler, uses a type of C++. You will type your commands in through here. This, for instance, defines what the individual pins will do and so forth. That aside, all you got to do on your PC is you got to write the program. You hit what is called verify. I call it compile. But if you wrote the program right, and if you look down here at the bottom, you'll get a message that says done compiling, binary sketch size. This particular little program used 856 bytes, and I still have 14,336 bytes. I still got about over 13,000 left that I can use. Next step, of course, you'll go up here under Tools, you'll go to Serial Port, and you'll select the appropriate serial port. In the case of this, it's COM1. Then you'll hit the upload switch, and hopefully, if everything goes right, it'll come back with a nice little message. If it comes back with a lot of red warning errors, that means something went wrong. Your basic layout in this whole system is shown in this illustration. Here is your PC. You write your program, you hit the upload switch, and through a serial port, it will travel through a cable to some sort of converter. Now, while this is a PIC 16F84, it's the same thing with Arduino, same kind of deal. These microcontrollers operate off of 5-volt logic, but these serial ports don't operate at 5 volts. They operate at a completely different, incompatible voltage. So you need something like a Max 232 for a serial port that will convert this plus and minus 12 volt DC signal to 0 and 5 volt TTL logic. Pictured here is one type of Arduino board. It's an early board. It's still in production, I suppose. If you notice up here, here is your RS232 connection. That goes directly to your serial port. Here's a 78 ohm. This is your voltage 5 volt voltage regulator. There's your 16 megahertz crystal, your reset. There's the Arduino itself. And note down here, here's a power connector. This is for a plug-in-the-wall transformer, usually 7 to 12 volts. The regulator will change it to 5 volts, which is what the digital circuitry here will use. And the conversion circuitry for the RS232 serial input is these transistors and parts along here. Notice along the outside edges up here and down here, here's your digital pins 0 through 13. Down here is your analog pins 0 through 5. They brought them out to a connector so that you can easily connect cables, plug-ins, or whatever to connect up a prototyping board. It also brought the 9 volts. It goes into the connector out. Here's your ground, and there's the 5 volts from the regulator if you need it. This board, of course, as you see here, is circa 2005. All right, here's your RS232 port on your PC. It consists of a 9-pin DIN connector. This is no longer used on most newer computers. You won't find it on new laptops, and I don't think you'll find it on most desktops anymore either. Manufacturers want to save a buck, so it's no longer around. If you really want to use this, it's real simple. If you have the board in the previous frame, it's just a simple 9-pin cable. Plug it into your computer, plug it into the board, apply power, boot up the software, and you're off and ready to run. If your computer does not have a built-in RS232 port, you can get a USB to RS232 adapter. Alright, this is a more modern board called the Uno. It's really the same as the other, with a notable difference. Over here we have a USB connector. This will connect directly to your computer's USB port. It has a chip built into the board, an integrated circuit that will convert USB to TTL levels. Again, your connections are brought out here to the edge. Here's digital pins 0 through 13. Down here again is A0 through A5. That's your analog channels, and of course, this is also puts out 3.3. Some parts today use 3.3 volts. I generally don't use them. Alright, this is a device that I use quite a bit. It's the really bare bones board from a company called moderndevice.com. Looking this over, it's just a simple circuit board. Over here on your left, here is a connector that will connect to a separate serial to TTL converter. Here's our ATmega 168 chip. If you look down here, these are push pins. It will plug directly into a prototyping board. Here we have a 5-volt on board regulator, and here is our power connector. It can connect to a plug-in-the-wall power supply or whatever you have. Here was a project we did in my college class. It might be a little hard to see on this video, but the bare bones board is right down here in the middle of the cluster of this bunch of circuitry. This was a demo board we built in one of my classes. This up here is a Micrologix 1000 programmable logic controller. All it basically did was to tell the Arduino chip, which was the previous board down here, what to do. Your basic, even most basic Arduino chip was programmed simultaneously to control a stepper motor, including speed control, and count how far it actually went. It could forward and reverse and operate a motor control circuit. Off the picture down here is a model airplane servo, and over here is an AC control circuit that can handle up to 20 amps of power. And it could very precisely regulate the power output. In this case, in this demo, we used a 40-watt light bulb, but I have used electric motors and other devices. All of this programmed at once in a little 28-pin chip. That can do a lot. Here is another version of the bare bones board, again from Modern Device, called the Arduino. If you look closely at this, all of the digital I/O pins and some of the analog are brought out to a single edge connector that can plug into a prototyping board. Up here is where you would plug in your serial interface. You can select different power sources either through the proto board, through the plug-in power supply, or you could even power it from your USB port. I recommend don't use your USB port. If you wire something wrong, you can damage it. Alright, notice the previous two boards did not have built-in serial converters. This is a USB to TTL converter board. This is also from Modern Device. I built this. It essentially comes with that already mounted. You don't want to get into trying to solder a bunch of surface mount components as a hobbyist. You can configure the output to do whatever you want to. This product works great. This is part of another different kit from Modern Device. It goes to a standard RS232 port that we talked about earlier. And again, here's the edge connector that will plug into any of the bare bones type boards. And not just theirs, others will work with this just as well. It's inexpensive. It was easy to build. Let me give you a word of warning. If you don't know how to solder, buy an assembled unit. Here's a picture of how either the BUB board, the USB or RS232 converter boards will plug into the edge connectors of the bare bones boards. Or you can buy a separate cable that has the electronics built in and then just plug in the cable. It's that simple. And then the cable or connector goes to the computer. Here's another example of the bare bones plugged into a prototyping board. These are light emitting diodes. These are resistors. This is wired up in such a way that if I program a high or on, say, digital pin 3, a high in this thing is 5 volts, the LED will light up. Again, your serial connector would have connected up here. There's your power input and so forth. This is another picture, photograph of it, what it actually would look like if you wired it up that way on a prototyping board. Note here on this type prototyping board where the blue is ground and the red is positive, there's 2 pins that you can solder into here and get your power directly off the board through to this point if you want to, or you could go over here and jumper it back. This is a gadget board that I built using the bare bones. You can see it up here. Plugs into this Radio Shack card. Then I run the connectors over here to a collection of female connectors. Easy to jump off into this little prototyping area. I changed the UL in 2001 to a 2003. It's used for driving electric motors, solenoids, relays, stepper motors, and so forth. The Arduino is not capable of driving these things without something to boost the power. This section in here is a 5-volt regulator. You can put AC in. Over here is my RS232 to TTL converter. This over here is a DS1307 real-time clock circuit. This is another type of Arduino board. This is called a Mini. Your AT-Mega chip is actually this surface mount device in the center. This plugs into a proto board. You have to just look at how it hooks up. It also needs an external serial port converter circuit. Okay, that completes our basic introduction. I hope this was helpful. My next collection of videos will go into how to program and actually connect the Arduino up to do real things. Thanks for listening to the video.